Hello, welcome to this code rate session. My name is Joaquin Monedero and I am going to show how to build a simple cross-platform game. In this case, I developed a clone of the well-known Bejeweled, where you have to match 3 or more jewels, switching them with the adjacent ones. So first of all, I'm going to show how the application is running in the both different devices, Android and iOS. So let's start with Android. Let's execute the application. So the first thing we find when start the game is a Hall of Fame list with the highest scores, and if we press the play button, we start playing. Every transition that is done in the game is performed using FireMonkey animations. So we continue playing, we gain points, and the time goes by. So when the time is finished, the game is over. So now that the time is over, as we got a high score, the game asks us for our name. So we can introduce it. And here are our name. Now I'm going to show the game how it runs in the iOS simulator using Making Cloud. So here is my remote connection with the Making Cloud service, and this is the iOS simulator when I'm going to run the application. So it works like the Android version. The code is the same. So press play to start playing. Match some figures. Make some points. The refresh is far better than the Droid to screen application, but the performance is the same. So as time goes by, we will be asked for a new high score if we got a score high enough, so we can provide a name, and it will be reflected in the score, as it happened with the Android version. Now that I have shown how the application works, let's design the interface. We will start from scratch with a new mobile application. We will start with the button panel that will host the play button and the game over message. So I'm going to align this to the button. Insert both the button and the label. Both of them will be aligned to horizontal. The next step will be insert a tab control that will represent the main area to the client, and this tab will have three tabs. Okay, so one will be for the game, the second one will be for the high scores. It will be also aligned horizontal. And the third one will be for to provide a new name for a new high score. So those are the necessary items for this tab. With this, we have part of the interface. The next step is to design the area for the game itself. So I will insert a new panel for the top area that will host both score and time. And the time will be a status bar, progress bar. So these controls are going to be aligned to the right. This label will be for the score title. This one is going to keep the score count, and this one is going to be the time title. For the status bar, the progress bar, sorry, we will have a max value for 60 seconds, and initially it's going to be also 60. The last step is to provide a layout for the game. This is going to be the game area, and this one is going to be the board itself. It doesn't mind the size of the board. We only need it to be present because it's going to be resize in runtime depending of the size of the screen of the device. Now I'm going to introduce a timer that is going to be in charge of decrement remaining time that we have for the game until the game is over. So the interval is going to be 1000 milliseconds. So each time that the timer ticks, we will have 1 second, one less second. So the main function of the timer is to decrease the progress bar value. Now we are going to remove these awful tabs from our game interface. It is done selecting tab control and changing the tab position to none. This makes impossible for the user to change from one tab to another one, but we are going to provide a way to do it via the play button or when the game is over. This requires introduce some special actions. So first is to add an action list and create a new standard action. and we are going to select this very one. We need 3, 1 per tab. Okay, so we are going to change transition type to a slide, and then the rest of the settings are fine. Now we have to set the particular tab for each action where the transition is going to be done. For the first one, we are going to move to the first tab. For the second one, we are going to transition. We are going to move to the second tab, and the third action is going to move to the third tab. Now, every time that the user press the play button, the game board has to be shown. So this is done. This is done executing the transition action manually. So we are going to execute the transition that moves to the first tab. Pressing the button will present the first tab with an sliding animation. In case of the timer that we insert before, when the progress bar value arrives reach 0, what it's going to do is to present the game over message and move to the Hall of Fame tab. So for this we are going to check if the value is 0 or under 0, and do the same that we did before. So this is the label 1. So this way we make the label visible, so the game over message is shown. We disable the timer, so it is not going to be decreasing the time anymore, and reset the progress bar value to the initial one. So with this we get the initial state of the game after it finished. Now we have to make the timer start to work when we press the play button. And maybe hide the game over message the first time that the user starts the application. So with a few lines we are now controlling the main game flow. We are going to add a score property. So anytime that we set a new score to the game, it is going to be visualized in this label. In this case is label 5.text will be and now when the time is over, we could check here if check high score if the score that the user got is a high score, then we could move to the new high score tab. So now the last thing to get the flow complete is to create a handle for this button that will save the high score and the name, and move to the Hall of Fame tab. That will be also done the same way that we did before. Now with this everything is closed. So now we are going to continue with the game itself. Usually this kind of games use 7 different figures. So we are going to insert the figures, the pictures for the jewels directly in the form, so we don't have to load them from external storage. They are going to be invisible, and we are going to replicate it 7 times. Now we are going to load the pictures into the image control. This is new in XE5. The image now have a multi-resolution bitmap editor. The bitmap property continue existing, but it is not used anymore. So here we choose the image that we are going to use. This is the first figure. If I will have better resolution images, I could add them to this editor. So depending of the device that the application is run, it will select the better image for that particular resolution, using the scale as an index, depending of the resolution of the device itself. So if I will have it a new picture for it, I could add a new one, fix and scale, and load a better resolution image. At the end, the application is going to use the same DPs, virtual pixels in the screen, but as when the image is drawn in the screen, they use the whole real resolution. The pictures will appear better, but in no way this is used as a way of rescale images depending of the image. It is only to provide a way to load better resolutions for higher resolution screens. So as I'm not going to use this one, I'm deleting it and closing the editor with a new image. For the next one, for the rest of them, I'm going to do the same operation, but with different pictures. So the next one, This is the third figure. Fourth. Fifth. The sixth one, and now the last. So now that we have all of them, we are going to set width and height properly. Now that the interface is almost done, is mainly complete, I'm going to change to the final project, so I can continue explaining other things that has been done by code. First of all, the initialization of the application. In the first place, we can see the code that is in charge of resize the board and the images to fit the screen. Cells width and height are calculated depending on the space that we have and the number of cells that we want on the board. Then the board width and height are set properly depending on the cell size that we have calculated, and the board is relocated to be placed on the center of the available area. That is the main layout. Next, we can see a loop that creates and initializes the animations for the highest score, name and point labels, so they appear from the bottom up to their final place in the Hall of Fame table. So this function is in charge of create the proper animation and set it up with the stop value where the label should be. Each time that the Hall of Fame tab is shown, they are populated with random starting values, so they can move and they reach their position at different times. Now we are going to see how to populate the board itself. It is done here within this loop that is executed once per cell. The T-cell object is just an T-image object that has some extra public fields to store the animations needed to move the figures smoothly, horizontally or vertically. Later, some events are set to act to mouse events, and later some two animations are created to allow us the movements of the cell. One for vertical movement and the other one for horizontal movement. Later we have an effect that is going to allow us to select one cell and an animation to make the glow effect of selection appear and fade smoothly. All the images that we have created are empty, so each time that a new figure appears on the board, and an image needs to be filled with that figure's picture. This is done in this procedure where, depending on the contents of an array that stores the current state of the board, it assigns to the cell that is going to represent that figure the image depending of their coordinates. So this function selects checks the type of the cell and returns the one of the images that we loaded into the form in previous steps. They are those images. So when we have the image, we retrieve the cell that is going to display it, relocate to the correct position in the board, and assign the image to the shell. This is done by assigning the design time image to the cell. This is the only code that is done with conditional compilation, because it is different depending of if it is before X5 or X5. As a multi-res bitmap feature is available only on X5, we need to choose if we have to assign to the bitmap property or to the multi-res bitmap property. Now we are going to check how the floating text with points are implemented. So this is the code that is executed when we match the same cells, or there is a matching cascade and a multiplier appears. So we first create a text that we have that we position in the over the cell as a starting point. We apply a glow effect and create the animation that is going to make it move towards the upper side of the screen. So depending of the type of the text that we are doing, if it is a simple score or it is a multiplier, we apply different settings. So here we set the starting position and the final position. So when everything is set, we just start the animation, and when it finishes, it will just disappear. To move the figures around the board, we are going to use the animations that we created before at initialization time: horizontal animation and vertical animation. So when the user moves the cell to try a match, it is executed here. So first thing is to retrieve the cells that for the source and the target positions, and check if it is moving or it is returning. So when the user tries a movement, animation is set, so both cells are going to move to the position to the other one, and when the animation finishes, a code is executed to validate the movement. But if after the movement is validated, if it doesn't match, so the movement is invalid, this code is going to be executed again, but the reverse code, the reverse parameter is going to be true, and what is going to happen is that the animation is going to be reverted, so the images are going to return to their original position. Finally, the fall movement, when the match is done, is performed in a similar way. But what happened here is that each time that the fall has to be executed, several pieces are going to fall down. So the movement is not performed to the right until the whole animation is finished. So we need to count the failing cells So when all of them has finished, the unfinished event is going to perform the movement onto the array that represents the board. This is the event that is executed. So each time that it's executed, it decrements the counter, and when it is 0, it means that all the animation has been performed. It applies the movement as I said before. To finalize, let's have a look on how to handle the file where the Hall of Fame table is stored. So to load and save the file on the application home directory, we will use this system.io utils path get home path method. So we get a directory where we have rights to save. This is supported by Windows, Mac, iOS and Android platforms. It is worth to have a look on the path class to get a complete set of functions that provide us with different directories in the device. The rest of the code will manage the arrays that represent the board state, apply movements into this array, remove matched cells, and so on. There's a lot of room for improvement and new features on this game. This application was developed in no more than 10 hours. If you have any doubt, you can contact me at joaquin.monedero@embarcadero.com. Thanks for watching.
Kenneth asked about making the source code available to the little game example.
Yeah. Yes. I suppose that I can publish through a post in the Embarcadero web blog. Sorry.
How can people get a hold of you, Joaquin, if they want to ask you any questions?
Sorry?
Is there a way for people to get a hold of you if they have any follow-on questions?
My email address is joaquin.monedero@embarcadero.com.
Okay.
It's just the name with a point, a dot in the middle. So you can feel free to write to me.
Yeah, I know there's several people asking for the download. Okay.
So you're going to post the download on blog.embarcadero.com?
Yep. Do you have something?
Yeah. Are you going to post the download link on blogs.embarcadero.com?
Yeah, I'm planning to doing it.
Okay.
Yep. So check that out, everybody. Coming soon.
I'm just putting his blog link. There's nothing there right now, but people can stay tuned to that. Okay, there was one here. I'm not sure. Will we ever see more transitions? I guess he's talking about image transitions
or animations and
animations. Lewis is asking about flip. Would be nice.
Yeah, on iOS you have that page curl or flip.
Oh, I see what you're saying. Yeah, I think Adobe has some of those where you can peel the corner.
Mm-hmm.
Okay, there is a transition like that. I'm not going to remember the trans. It doesn't page curl, but it does let you go from a corner to the other corner on an image transition from any corner.
So the question is if there's a guide for what paths for various locations for files and whatnot on the different devices, if there's a place we can find that.
Yeah, there is a whole class that supports different locations that are standard in the different devices. So you don't have to worry about what is the real path for all of them. I use that very one that is local to the user of the device. In case of a desktop computer, it is for each user, and in case of devices as phones, they are supposed to have only one user, so it is the one that you use. But there are a lot of different path function for paths. I think there are for temporal files and so other locations of interest.
Okay, great. Here's a question about why do not prefer OpenGL?
Well, FireMonkey makes all the use of graphics abstract for the developer, so you don't have to be dealing with low level primitives of DirectX or OpenGL. But FireMonkey at the end you use DirectX for Windows that is supposed to be more spread in this platform, and for the rest OS X and iOS they use OpenGL as well as in Android. So FireMonkey decides what technology to use depending on the platform it is running.
All right. A long time ago, I created the same game using VCL's T-Draw grid and was thinking about porting it to FireMonkey. Well, you are the first. So there we go. See, it's always good to see what you can do on FireMonkey, and that it's inspirational for everyone else that has have the same thoughts, I guess.
Well, those kind of games are some easy. I think it's the first thing that everybody makes once they want to do something. Tetris, Arkanoid, and some other games are the first choice to clone.
Have you ever used Corona SDK or any of the other game development platforms that are out there?
Not at all.
Okay.
The effect I was thinking about that's like the curl or page turn is the T-swipe transition effect. So it does a swipe from, you can choose a left side, right side, top, bottom, any corner or any coordinate, and it does a swipe, and you see the back side of the image as it's peeling. I forget who it was. I think it was Lewis that wanted like the flip or something. T-swipe transition effect was the one I was trying to remember. Sorry.
There it is, Lewis. Oh, he's talking about transitions for changing tabs.
There's an example, which is the tab swipe.
I
samples.
I think Sarina published it.
Yeah. Yeah, if you go into public, sample, public, Red Studio, public documents, user public documents, Red Studio, 12.0 samples, there's a tab slide either in the mobile code snippet or FireMonkey samples.
That's in FireMonkey mobile tab slide transition.
Yeah, tab slide transition. So you can load that one up, everybody that's got XE5, and it does a nice animated effect from tab item to tab item.
Yeah, so I guess he's looking for more options there for how to get more tab transitions there.
Oh, I see. Okay.
So the question here, how can I do, or what can I do for the best frames per second? What about background surface painting?
I'm not sure. I was not worried about performance, but to see how FireMonkey was working, so I can't say. It will require a little of search by me. So, well, best FPS practice will be try to maybe I use a lot of animations. One of I will start lowering the quantity of animations I created for the transitions of the pieces in the board. But I can say how to techniques for increase the frames per second.
Yeah, and the more surfaces and the more objects and the more components, and the more movement you have, the slower your frames per second.
Yeah.
I will also say that maybe writing everything in an image instead of using a lot of little images as I used, it will improve the performance also.
Yeah.
but it will avoid you to use FireMonkey animations. You will have to work yourself on the movement and timing routines.